Hey you guys, welcome back to my YouTube channel. In this video, we've given this typical question, which is precision measurement. And then if it's your first time watching my video, may you kindly subscribe, become the part of the family by subscribe to my YouTube channel and click the notification bell so that you'll be notified whenever I post a new video. We've given question 4.1 says calculate the distance x in figure 1 below. So about that, we want x there. Want to calculate what x we're given all of these guys. So how can we get the value of x? As you can see, x guys is simply what we have to sum up this 120 something, right, plus this piece. You see that piece there, the piece that is left there, and that little piece. If we can add this piece and this piece and this 125, will get what the distance of x. Hence the distance of x, it's all of that, you see. Hence the distance of x is all of this. So if we can find what is the piece here, the size of that piece, and get that size of the piece and then adding there, then we'll be fine. Let's see how can we go about that. We'll see how we manipulate these things around. All right, so I can form a triangle sort of here. All right, so it will be the same beside because as you can see guys, we're given these guys, this we have the same. If we have say these diameters are the same, with the exactly same diameter, the same angle, into that angle, all of those things. So we can use this. Since this thing identical, these two identical, I will use the one part. I won't use all of this part. Let me use this side guys. So I can call can name my point, can name this B. All right, this point there, and also that point, I can name that C. All right, so name this E, can name that F there. All right, so this is what we have, right? So this is O, it's our center then. So I can create a triangle like that. I can construct the triangle here. You see, if I do that, we will have some triangles. So guys, like this. Also here I have the triangle. As you can see there, I formed the triangles, two triangles there. Right, I can call this angle here, I will call it theta. Take note, this angle there is theta. So all right, that it is simply our theta, isn't it? So that is what we have. Are we together? So what about this? I can call this angle I can say phi, like that. I can call it phi. Can call this angle there phi. All right, we have that now guys. So we have two triangles. So I want theta. How can I get this guy theta there? Theta there, I have that theta there, isn't it? So theta, we have given here 65. All of this angle, they say it is what is 65. 65 divided by 2. If you divide by 2, this will be 32.5 degrees. So that is our theta. All right, but getting phi guys, if you can check, phi is here will forms what? A right angle triangle. How can I get that? Since it forms a right angle triangle, phi will simply equals what? 90 minus 65 degree. You understand? Here this will be 90 degrees. I have the whole of this angle, guys, there. The whole of that. If I subtract, I will be left with the remaining part. Hopefully you see there. And we have something like this. All right, so we've given the whole of this, guys, which is what is 60. I want this angle. This is theta, isn't it? Remember, this is the whole angle, is not theta. It's the whole angle that we've given them. But I want this. This is simply what phi. If I want this, phi will be 90. Remember, this forms a 90 degrees. Will be 90 minus 60. So this is how it go about. You understand? Which you will get 25. So that will be what? Phi will be 25. Simply equals to 25 degrees. That thing is taking place here. All right, we have that, which is 25 degrees. All right, so that is what we have. All right, that is what we're supposed to have. So we're supposed to calculate x. Looking for the thing, looking from things, we're supposed to find the value of x. So the value of x, we'll try and get the value of x. If we can try to get the value of x, we'll try and find the value of x. We'll try. Okay, how can we formulate the formula that will suit us to calculate the value of x? So I can say this x can be equals to what? If we try to formulate the formula, can be the whole of this, which is 125, right? 125, then minus what we're supposed to minus, then right, EF. Remember, this EF is the same, even this part will be EF, so I don't want to write it because they're identical. So if we subtract that, will be what? 2 EF, like this. So since we have subtracted that, plus 2AB plus 2AB. All right, that is what we have so far, plus the aim is to get 2BC. So that is the aim, guys. The aim is to get all of those things there. The aim is to calculate EF, AB, AB. You can say this thing, guys, from, I can call this there, it can be A, that point there, can make that point to become what? A. So we have A. The aim is to calculate AB, BC, EF, then we are good to go. So let's go about and have that there. So let's go about and calculate these, guys. So you can say in triangle CEF, just specifying so that the examiner it will know. Let us find, we can find, remember we're looking for what? Let us find EF, guys. We want this here. What is limiting is if you can get EF and get AB and BC, then we can able to get the value of what? Of x. So looking from that, here we will need EF. So there will have a triangle ECF. Where is that triangle? Here it's our triangle there. If I can take out that triangle there, we'll have something like this. Here it's our triangle. Here it's our triangle. We'll have our triangle. Let me just construct the triangle first. So we have the triangle. This point we can call it F. We have FE. As we can see there, here we have C. We have said this is alpha. This it was what? Alpha. What is alpha? We called that to be what? We called that to be let's check, 25 degrees. The alpha there, it was 25. So here I have 25 degrees. Then remember, I'm taking out this triangle. Here we have 35. The length here is 35. From there going down here, this is simply equals to 35 millimeter. So we have this 35 millimeter. So we can find EF, opposite over adjacent, which is tan. So can have here our tan. We're applying a trigonometric ratios. Tan here, this it was phi, isn't it? So this will be what? Will be 25. Will be 25. We have 25 degrees. Obvious is opposite over adjacent will be 35 divided by EF. Okay, so oppose, this is adjacent. Opposite will be that. All right. Looking from, sorry about that. That will be our opposite. So looking from the things there, that will be our opposite, right? So here we'll have EF on the top, then divide by 35. Right, we want EF, we multiply there, we'll have EF to be equals to 35 multiplied by tan 25 degrees. Then try and punch this, we'll get EF will be what? What will be the value of EF? EF will simply equals to 16,321. Obvious it's in millimeters, since this it was in millimeters. So by the way, that is what we have. We have now EF. All right, we are good, at least we're approaching. So we have this guy now, EF. So the one that I've highlighted. Now we're left with AP and BC. So how can we find those? All right, we can go to triangle BC. This triangle, I'm talking about this triangle there, this portion, the one that I'm highlighting, BC. I can take out that triangle. We have the triangle there. Triangle. You can see there. Can tell the main examiner this. We can call this. We have there in triangle BCD. All right, this is our triangle. So here we have A, B. All right, so from there we have BC. Let me call this, or this is D. You can call that D. In triangle BCD, this triangle, obvious here we have theta, that it was theta. Our theta from that triangle is what? We got theta to be 32.5. That is our theta. Remember, it's the same as this guys here. Theta is the same as that. We divided that by 2, then we got 32.5 degrees. So we want that theta. We have the theta there. So our theta, our angle there, that which was theta, which is 32.5 degrees. So we have D here. So the aim is to calculate AB, the side AB. We'll use our trigonometric ratio tan. So we'll have tan, the angle there is 32.5. It's what's supposed to be opposite over adjacent. All right, here it's our we have to have a opposite. Actually, here it's our A. This is supposed to be B. A is here. This is supposed to be B. Here I've written this is supposed to be B, guys. This is supposed to be C. Don't know why I wrote this. This is supposed to be C. All right, is B, C, D. So opposite side will be BD. This is opposite. All right, divide by what? Adjacent. Adjacent, which is what? Which is BC. All right, we have here BC. All right. But take note there, BC is the same as what? It's a radius. If we can take note here, it's BC. Oh no, BD is the same as radius. This part is the same as radius. BD is the same as what is radius, because this is the radius of the circle. So that guy is the same as radius. The radius there, we have 25. Our diameter is given to be 25. We divide that by 2. 25 divided by 2 will get 12.5. All right, so here we still have tan 32.5. Looking from this is the same as our diameter. BD is 12.5. So we have that diameter BD is 12.5 divided by BC. 1 BC you multiply by BC, also you divide. So by tan, if you do that, you'll have BC. This will simply give you 2.5 divided by tan 32.5. Then we punch this, supposed to get that the value. Therefore the value of BC simply equals to what? BC will be 19.62, obviously millimeter. We have that. So what are we left with again? Now the aim is to calculate now BC. We have this guy here. Let us get now BC. What the we had, okay, we had BC. All right, now let us get, AB. How can we get AB? Let's check. Do we have AB? It's AB or what? Here I have supposed to be EF, which is fine. Supposed to become EF. Right, BC. We did calculate BC. We have BC. We don't supposed to have what do we have? This AC will be simple. Okay, AC there's no problem. This will be simple. The other one, what this AP will be simple. With what? AP is simply just the radius. Looking from here is the radius, so no problem. That will be the radius AP. AP is the same as radius. AP is the same as what? As radius. So we can calculate our things now. We can have our x, since our x is equals to 125 minus 2EF plus 2AB plus 2BC. So let us find that we have 125 minus 2. What is EF? EF is 16,321. We have this 16,321 plus we have 2. What is AP? The same as radius. The same as the radius. Radius is the same as 12,5. Okay, plus 2. What is BC? Here it's our BC. It's simply 19,62. So punch that, we'll have the value of x. If you punch all of this, punch all of that, we'll have that to be 156,6 millimeter. That is our value of what? Of x. That is the value of x. Hopefully guys, you're with me. All right, that is how we have attacked this question. All right, that is how we attack this question. So that is how we attacked this question. Let's check now 4.2. It says there 4.2, a gear with the modulus, which is that its M is 10 millimeter, a pressure, angle pressure there, which is 20 degrees, is to be tested for correctness by using a constant chord method. You see, this is a constant chord method of testing. Calculate the constant chord width and height. Calculate the width and height. Okay, let us find width and height. So we're supposed to use width and height. So let's find the one with width and height. Okay, with width and height we know, but with width we'll have our width will be equals to pi multiplied by what? Modulus, divide this by 2, multiply this by cos square theta, whereby it's a pressure. Pi, the modulus is 10, divide by 2, multiply by cos, the angle, the pressure angle is what is 20. Here is squared, it's the same as like this. Punch this on the calculator. Let's find our width. We can get the width. Using the width method, we have 13,87 millimeters. All right, so again we can try and using now height method. They said we should width and height method. The formula, obviously, if you know this, will be modulus into 1, isn't it? Minus pi over 4 into sine theta multiplied by cos theta into that, if I'm not mistaken. Yeah, if I remember, is this formula. We have our height, modulus is 10, we have 1 minus pi over 4. The pressure angle theta there, it was 20, multiplied by cos 20. Then if we punch all of these, we'll have that our height 7,48 millimeter. All right, so this is what we have, guys. So thank you for watching. May you kindly subscribe to my YouTube channel and click the notification button so that you'll be notified whenever I post the new video. All right, thank you guys for watching. Feel free to comment and to share this to your fellow classmates. All the best.